Got it? Hello everyone, I am Dr. Kalpana Singh, Associate Professor in IIMT College of Polytechnic. Today I am going to discuss topic water and its treatment. Like air, water is one of the basic and precious compound which is prime importance for the life on the earth. As you know, so in this lecture I will discuss the importance of water as an engineering material. As an engineering material, water is used for producing steam in boiler to generate hydroelectricity, steam for engines. Water is used in the construction industry in the form of concrete structures for manufacturing purposes and as an excellent solvent for chemistry. So water is an universal solvent which can dissolve something to everything. That's why it is very essential to understand the various characteristics and parameters of water. In this lecture, I will discuss what do you mean by hardness, what is the unit of hardness, what is the water treatment processes, and what do you mean by boiler problem. Now, what do you mean by hardness of water? Basically, the soap consuming capacity of water is called as hardness of water. As you know, water which can easily form lather-based soap is called as soft water, and the water which does not give lather-based soap, instead of it gives curdy precipitate or white scum, is called as hard water. You can check by taking a small quantity of soap and add it in two different samples of water. What will happen? The sample one which give lather-based soap is called as soft water, and the sample two which forms curdy precipitate is called as hard water. Now we will discuss what happened in case of curdy precipitate. By taking a chemical reaction, we can easily discuss. As you know, soap is sodium acid, so it is called as sodium stearate. Look at this reaction, C17H35CONA. It reacts with calcium chloride. What do you mean by calcium chloride here? Basically, hardness is caused due to sulfate, magnesium chloride, magnesium sulfate, ferrous sulfate, aluminum sulfate, calcium bicarbonate, magnesium bicarbonate. In short, we can discuss in detail. These salts are responsible to cause hardness in water. So what happens if calcium chloride is present in the hard water? Then what will happen? Calcium chloride react with sodium stearate, C17H35COONA, and it react with calcium chloride, form calcium stearate. Once sodium is replaced by calcium, because sodium is monovalent ion, calcium is divalent ion, so its replacing capacity is more as compared to sodium. That's why calcium can easily replace the sodium of sodium stearate, and as a result of this, in this product, finally sodium stearate is converted into calcium stearate. In second reaction, if the water contains magnesium sulfate, as you know, magnesium sulfate is also used. Magnesium can easily replace sodium, and as a result of this, it will going to form magnesium stearate, C17H35CO whole twice Mg. In this way, what will happen? Once sodium is present along with soap, stearic acid, the soap gives lather. But what happens when magnesium can easily replace with sodium, then it will form magnesium stearate, and here there is no lather. Instead of lather, white cuddy precipitate will be formed. Now we will discuss how many types of hardness. So depending upon the hardness causing salts present in the water, hardness is of two types. One is temporary hardness, other is permanent hardness. Temporary hardness means it is not going to exist for a long time. It is a very short time. These salts can easily exist in a very shorter period, and it can easily replace. That's why it is called a temporary hardness. So first we will discuss uh, the calcium bicarbonate and magnesium bicarbonate. These salts are major culprit to call temporary hardness in the water. So temporary hardness, you can say, students, it is caused due to presence of calcium bicarbonate and magnesium bicarbonate present in the water. What will happen when calcium bicarbonate is present in the water? This water sample, if you start heating, then the calcium bicarbonate can be easily converted into calcium carbonate, water, and carbon dioxide. Similarly, if magnesium bicarbonate is present in the water, what will happen? It is going to convert into magnesium hydroxide and carbon dioxide. So in this way, either calcium bicarbonate is present, magnesium bicarbonate is present. By simple heating or simple boiling the water sample, we can easily convert it into calcium carbonate, or if magnesium bicarbonate is present, it can easily converted into magnesium hydroxide. In this way, the hardness can easily remove. That's why it is called a temporary hardness. It can be called as alkaline hardness or carbonate hardness. What is the reason behind it? Alkaline hardness means the calcium bicarbonate is and magnesium bicarbonate is alkaline in nature. As you know, alkaline substance or alkaline solution, the solution which pH is more than 7.5 is called as alkaline solution. So calcium bicarbonate by nature alkaline, magnesium bicarbonate by nature alkaline. That's why it is also called as this type of hardness, alkaline hardness. It can be called by name carbonate hardness because this hardness is caused only due to presence of bicarbonate of calcium and magnesium. That's why it is also called as calcium carbonate hardness. It so many times it can ask in exams. That's why it is very important to understand the temporary hardness, the alkaline hardness, and the carbonate hardness. The second type of hardness is called as permanent hardness. As the name permanent means it is not going to remove easily, so it is called as permanent hardness. Now we will discuss the salts which the major culprit, the salts which cause permanent hardness. These salts are nitrates and sulfates of calcium, magnesium, iron, and other metals. Nitrates, chloride, and sulfates. Say, for example, calcium chloride. If we are going to discuss calcium salts, it may be calcium chloride, it may be calcium sulfate. If we are taking magnesium salts, it may be magnesium chloride, magnesium sulfate, magnesium nitrate, and ferrous sulfate, aluminum sulfate. So these salts are responsible to cause permanent hardness in the water. Permanent hardness, again, I am going to remind you students, the hardness which can't easily remove by simple boiling or simple techniques is called as permanent hardness. There are so many techniques. By using these techniques, we can easily remove the permanent hardness, like simply by adding EDTA. EDTA means ethylene diamine tetraacetic acid is a compound. By what we have to do, a small amount of EDTA we can easily add inside the hard water, and this EDTA is capable to remove all kinds of hardness. So we can use EDTA. Other methods, ion exchange method, geolite process, which are very important. And these methods, this softening process can easily remove the hardness. Now, before discussing the softening process, we have to understand the degree of hardness. What do you mean by degree of hardness? Basically, all kinds of hardness, like so many, just calcium chloride, calcium sulfate, If you are taking example, magnesium hardness, magnesium nitrate, magnesium chloride, magnesium bicarbonate, magnesium sulfate, aluminum hardness, it is caused due to presence of aluminum sulfate. Ferrous hardness, it is caused due to presence of ferrous sulfate. So all kind of salts can be converted into a uniform unit, and this unit is called as calcium carbonate equivalent. So all kind of hardness first converted into calcium carbonate equivalent, and then we have to calculate the exact amount of hardness. So what will be the formula and what are the region to convert all kind of hardness only in terms of calcium carbonate? Basically, there are two regions. First, the molecular formula or molar mass of calcium carbonate is 100, and other is calcium carbonate is most insoluble salt present in the water. On the basis of these two regions, we can convert all kind of hardness causing salts into uniform unit, and it is calcium carbonate equivalent. Now, how you are going to convert the all kind of salts into calcium carbonate equivalent? The formula is the weight of hardness causing salt or the concentration of hardness causing salt into molecular weight of calcium carbonate. As you know, molecular weight of calcium carbonate or molar mass of calcium carbonate will be 100. Like calcium, the molar mass is 40, plus carbon, the molar mass is 12, one oxygen 16, 3 oxygen, so 48. If we will add up 40 plus 12 plus 48, it will be going to be 100. So molecular weight of calcium carbonate will be 100. And these two, after multiplying, we will divide the molecular weight of hardness causing salt. It will be better to understand by taking an example. Suppose that a particular water sample contain 12 milligram per liter calcium sulfate. Now 12 milligram calcium sulfate, how can we are going to convert it into uniform calcium carbonate equivalent? By using this formula, what will happen? The weight of hardness causing salt, if 12 milligram per liter, so it should be 12 into molecular weight of calcium carbonate 100, it means 12 into 100 upon molecular weight of calcium sulfate will be 136. So 12 into 100 upon 136, and by using multiply and divide, we can usually calculate the calcium carbonate equivalent, and in this way we can easily convert the calcium sulfate into calcium carbonate equivalent. Now we will discuss units of hardness. There are 4 units which are used worldwide, and these units are parts per million. In short, it is called as ppm. Other is milligram per liter. Third one is degree Clark, and fourth one is degree French. I will explain one by one. Like parts per million. What do you mean by parts per million? As the name parts per million means 1 part calcium carbonate equivalent hardness present in 1 million part of water. Milligram per liter, students, as you know, milligram means 1 milligram calcium carbonate dissolved in 1 liter of water. So if 1 milligram calcium carbonate hardness present in 1 liter of water, this kind of hardness is called as 1 milligram per liter. Degree Clark, this degree Clark is mainly used in European countries. So it is the number of equivalent part of calcium carbonate present per 70,000 liter of water. Degree French, it is the number of equivalent part of calcium carbonate present 10 to the power 5 part of water. It means 1 part calcium carbonate equivalent hardness present in 10 to the power 5 part of water. And degree Clark, 1 part of calcium carbonate equivalent hardness present in 70,000 part of water. Now, what will be the relation between ppm, milligram per liter, degree Clark, and degree French? 1 ppm equal to 1 milligram per liter equal to 0.07 degree Clark and 0.1 degree French. So in exam, so many times in the numerical, you can ask how you are going to convert 1 ppm into degree French or degree Clark. I hope students, you can easily, using this formula, you can capable to convert 1 ppm into degree French or 1 ppm into degree Clark or milligram per liter. Now I'm going to discuss boiler trouble. What do you mean by boiler trouble or boiler problem? Basically, boilers are, as you know, boilers are used in industries to generate steam, and this steam is capable to rotate turbine, and finally mechanical energy through generator converted into electricity, and this electricity we can in the form of hydroelectric power. 70% Indian homes are using this thermal power electricity. So boiler are, in this way, boiler are very important. Now what happen inside the boiler if we are going to introduce hard water inside the boiler? So many problems we will discuss if we are going to introduce hard water in the boiler. Sludge, scale, priming, foaming, caustic embrittlement, and boiler corrosion. So there are 6 problems basically. These problems we will discuss one by one, and these problems are collectively known as boiler trouble. What do you mean by scale and sludge? Scale formation. Scales are hard deposit. What do you mean by scales? We can easily experience the formation of scale, and we can easily see in our household. If you can, what happen if you can take 1 glass of water, hard water or direct tap water, and put it in the pan and start boiling, then what will happen? When the water is half glass only remain, then you have to observe, you will notice the container contain 2 types of precipitate. One is a very hard and sticky precipitate which covered up entire container, and other is a small slimy precipitate. The small slimy precipitate which you noticed in the container is called as sludge, and hard sticky precipitate is called as scale. Only this scale formation is caused due to presence of calcium carbonate, calcium sulfate, calcium bicarbonate, magnesium hydroxide. Means, again I am going to remind students, scale are hard deposits which stick firmly on the inner wall of boiler. So scale are hard deposits stick very firmly on the inner wall of boiler. So very difficult, we can't easily remove this scale from the inner wall of boiler, quite difficult. So many techniques through which we can easily remove the scale from the boiler. So the scale forming impurities are calcium carbonate, calcium sulfate, calcium bicarbonate, magnesium hydroxide, etc. Sludge formation. Sludge, as I earlier discussed, loose, slimy and soft precipitate in the colder area of the boiler. Loose, slimy and soft precipitate. The sludge formed by calcium chloride. If calcium chloride is there in the hard water, if magnesium chloride is there, magnesium carbonate and magnesium sulfate is there in the hard water, it's going to form soft, loose, slimy precipitate. And this soft, loose, slimy precipitate is called as sludge. What do you mean by priming and foaming? Priming, due to rapid boiling, what will happen? Sometimes when the bottom of the boiler will very continuous heating, the temperature of bottom of boiler is exceeding. As a result of this, along with steam, water droplets are also enter in the steam pipe. The process of water droplets along with steam is called as priming. So what happens if priming takes place in the boiler and steam pipe? Basically, this wet steam what happened? It reduce the boiler efficiency. Anytime when the pressure will increase, boiler can be burst. And it can also reduce the heat of the steam and causes corrosion in the pipeline. So these are the problem. Corrosion in the pipeline, caustic embrittlement in the pipeline. That's why in the steam pipe, the water droplet should be avoided. Next, foaming. What do you mean by foaming? Foaming, the formation of foam or bubble at the surface of boiler water if the boiler water contains alkali and simultaneously oil. What happened? Alkali and oil, when introduced in the boiler at high temperature, alkali and oil both react together and form soap. And soap always appear in the form of lather, right? So foaming, the formation of foam or bubble at the surface of boiler water due to presence of alkali and oil in the boiler water. And this foaming also reduce the efficiency of boiler. These are the problems. Sometimes due to excessive heat, the boiler can be burst. Boiler corrosion. What do you mean by boiler corrosion or boiler corrosion? Basically, corrosion is due to presence of acids, hydrochloric acid, nitric acid, sulfuric acid in the boiler water. The boiler material gets corroded, and this, as a result of this, when boiler material gets corroded, the iron is converted into ferrous hydroxide or ferric hydroxide. And this ferrous hydroxide and ferric hydroxide is called a rust. So what will happen if we are going to take acidic water inside the boiler? It reduces the efficiency of boiler. It can cause cracks in the boiler, and due to thermal expansion, the boiler can be burst. There are so many regions, like if boiler water contains dissolved oxygen, dissolved carbon dioxide, dissolved salts like magnesium chloride. These are responsible to cause corrosion in the boiler water. Look at the reaction. What will happen? Iron react with water and oxygen. Corrosion always takes place in presence of moisture and oxygen. So what will happen? The boiler material made up of iron. So iron react with water and oxygen and form ferrous hydroxide and ferric hydroxide. This is the formula of ferric hydroxide, FeOH whole thrice, and ferrous hydroxide, FeOH whole twice. If oxygen amount is less, then ferrous hydroxide will be formed, and if oxygen amount is high, then ferric hydroxide will be formed. Ferrous hydroxide, brown rust, and ferric hydroxide, black rust. So rust is of two types. One is caused due to presence of ferrous hydroxide, which is appeared in the form of brown rust, and black rust is due to presence of ferric hydroxide. And it both are depend on the amount of oxygen present inside the boiler water. Caustic embrittlement now. Caustic embrittlement means due to caustic embrittlement. Caustic means alkaline substance and embrittlement means brittle. It means that due to presence of caustic substances, the boiler material gets brittle. And as a result of this, when boiler material gets brittle, what will happen? Due to thermal expansion, cracks will be generated. And what will happen when cracks once develop inside at the wall of the boiler, the water can burst out, and in this way it can cause accident in the thermal power plants Other problems, these basically alkaline material, it may be due to presence of sodium carbonate. Sodium carbonate is also alkaline in nature. It may be due to presence of sodium hydroxide. So what happened? Sodium carbonate at high temperature, sodium carbonate undergoes hydrolysis to produce sodium hydroxide. Sometimes what will happen? Sodium hydroxide is not present in the water, but if sodium carbonate is present, this sodium carbonate hydrolyzed and converted into sodium hydroxide. What will happen? This sodium hydroxide react with, look at the reaction, what will happen? This sodium hydroxide react with iron, it react with iron, form Na2FeO2, sodium ferroate. And once pure iron is converted into Na2FeO2, the boiler material gets brittle and it can easily develop cracks and it can easily burst out after thermal expansion. So how we now the question is how we are going to prevent from these trouble, and like scale, sludge, boiler corrosion, caustic embrittlement. So many methods through which we can prevent from these problems and we can protect the boiler. These methods are two types. One is external treatment, other is internal treatment. So what do you mean by internal treatment? Internal treatment means, as the name internal treatment means the process, the treatment is carried out inside the boiler water. Once the treatment is carried out inside the boiler water, it is called as internal treatment. It is called as internal treatment. Now this internal treatment is of four types. Means whatever the treatment we have to carry out inside the boiler water. Means directly we have to take hard water inside the boiler and we have to add certain compounds in the form of internal treatment. These, depending upon the nature of compounds, the internal treatment is of four types. Colloidal conditioning, it is very basic and primarily very prelim process. In this case, what will happen? We can add kerosene oil, glue, agar-agar and gelatin inside the boiler water. Basically, this process is carried out in case of low pressure boiler, not in case of high pressure boiler. This process is advisable. So next is what will happen if agar-agar, gelatin and kerosene oil added inside the hard water, inside the boiler in the hard water. They prevent the boiler from the scale formation, from the sludge formation, from priming, from foaming. Second is carbonate conditioning. As the name carbonate, carbonate means by adding sodium carbonate, we can avoid scale formation and sludge formation. So what will happen? But when we will add sodium carbonate inside the hard water, as you know, hard water contain calcium sulfate or calcium chloride. So what will happen? I'm going to take calcium sulfate as an example. What will happen? Calcium sulfate react with sodium carbonate and it going to convert into calcium carbonate and sodium sulfate. So in the hard water, in the boiler water, there is no more calcium sulfate. It means now the boiler can easily prevent it from scale, sludge, priming, foaming, boiler corrosion, caustic embrittlement. Phosphate conditioning. By adding, in this case, by adding sodium phosphate, we can prevent the boiler from formation of scale, sludge, boiler corrosion, caustic embrittlement. So what will happen? An excess of soluble phosphate is added to the boiler water. sodium phosphate. What will happen? This sodium, look at this reaction, what will happen? This, suppose that the boiler hard water contains calcium sulfate. So what will happen? Sodium phosphate react with calcium sulfate, and here the sodium can be replaced by calcium, because sodium is monovalent ion, calcium is divalent ion. So divalent ion can easily replace the monovalent ion. In this way, now the calcium sulfate form react with sodium phosphate and form calcium phosphate and sodium sulfate. So now the calcium sulfate is converted into calcium phosphate, and in this way it can easily prevent the boiler from scale, sludge, priming, foaming, caustic embrittlement in this way. Last is fourth method, Kalkana conditioning. It is very efficient and effective method. Kalkana means sodium hexametaphosphate. Kalkana is a general name. Its chemical name is sodium hexametaphosphate. What will happen? If boiler water contain calcium sulfate, the sodium hexametaphosphate Na2, Na4, PO3 whole 6 react, and this the product going to form Na2Ca4 PO3 whole 6. It means this calcium sulfate, the calcium is easily replaced, and as a result of this, it can easily remove the scale formation, sludge formation, priming, foaming, and caustic embrittlement. Last one is Edta conditioning. As I earlier mentioned, Edta is a wonderful chemical compound which is capable to remove all kind of hardness, and it can easily convert the hard water into soft water. So what will happen? Edta, so disodium salt of Edta we have to take, and we have to add inside the boiler water. Then what will happen? This disodium salt of Edta can react with hardness causing salt like calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride, calcium bicarbonate, magnesium bicarbonate, and in this way, instead of disodium Edta, it will be going to convert into calcium Edta or magnesium Edta or iron Edta or aluminum Edta. So there is no more disodium Edta in the boiler water, and in this way the boiler water can be prevent from scale, sludge, boiler corrosion, and caustic embrittlement. Thank you so much.